Hello, hello. Hi, everyone. I'm Jackie. Today, in this video, I'm going to cover my most asked questions by students, and they usually are also the most missed questions, and they're concepts that could come up on your SAT exam. So, per usual, let's jump in. So, first, we have this classic. We have a pair of linear equations, and the question says in the given pair of equations, A and B are constants. The graph of this pair of equations in the xy plane is a pair of perpendicular lines. Which of the following pairs of equations also represents a pair of perpendicular lines? So first, you must know that if you have a question with linear equations and I ask about perpendicular lines, that means that the slope is going to be the slope's negative reciprocal. So that's amazing. Also, when you have these type of questions, in order to properly see the slope, you definitely want to put them in terms of y. So I'm going to do that. So this would just be y is equal to negative 5/7 x plus 1 over 7. And then this equation, putting everything in terms of y, would be y equals negative a over b x plus 1 over b. Okay, so here I can see that the slope is negative 5/7. So if this line is the perpendicular to this line, to the negative 5/7 slope, then it has to be the slope's negative reciprocal. So that would be like saying negative a over b is equal to positive 7 over 5. Why is that? Because it's the slope's negative reciprocal, which means when I multiply, just for those that are new to this, when I multiply negative 5/7 by 7/5, the product will be -1. Okay, so I have that down. And just another way to see this, if I don't want to deal with the negatives, that if I multiply each side by -1, that's the same as saying that a over b is equal to -7 over 5, -7/5. Okay, and then I'm asked which of the following also represents a pair of perpendicular lines. So I'm looking for which one of the answer choices also provides this same relationship. So what I'm going to do is what I did above is rearrange everything in terms of y. So for example, this would be y equals -10 over 7x plus 1 over 7. And this one here would be y is equal to a over 2bx. And then minus 1 over 2b. The y-intercept doesn't really matter. But so in this case, we can see the slope of this line, it's -10/7. And the negative reciprocal would be that a over 2b. My pen died. Okay, so I have a over 2b would be equal to the slope's negative reciprocal, so that would be positive 7 over 10. And we can see that in our relationship up here, I had negative a over b was equal to a positive output. So this is not really what we're looking for. It wouldn't represent the pair that we have above. So I'm going to discard A and move on to option B. D. So option B, when we rearrange it, put everything again in terms of y. Which would be that y is equal to, again, -10 over 7x plus 1 over 7. That's easy enough to rearrange because it's exactly the same as option A. And this one here, it's almost identical to what we saw in A, except it's going to be negative a over 2bx and then plus 1 over 2b. And I can see the slope here, it's -10 over 7. And the slope's perpendicular to it would be, so negative a over 2b is equal to negative reciprocal would be positive 7 over 10. And we can see, or I hope you can see, that this matches the relationship above, where I have the negative a over b relationship with a positive output. And the only difference is that this is 2b, which you can see that's still the same. Oops. Well, 7 over 10, because, what's 2 times 5? 10. So we see that this relationship is exactly identical to this one above. And just to show too, if I were to multiply each side by -1, it would have the same relationship still, which would be positive a over 2b is equal to -7 over 10. And we see how that one directly matches, and that would be our answer. Wasn't that amazing? So amazing, so good. So next up, we have this one. So it says the functions f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? Okay, so first thing to note about the functions is that these are decreasing exponentially, meaning that as f of x decreases, x is going to increase. This is important. Why? Because the maximum value occurs. So this occurs at the least or minimum value of x. And they tell us in the problem that x is greater than or equal to 0. So this is occurring, the least value of x, in this case, where x equals 0. Okay, so now I just have to plug that in. So for function 1, let's go ahead and put f of 0 is equal to 33, 0.4, and then do 0 plus 3. So basically that's going to be 33, 0.4 raised to, well, cubed, which let's see what that equals. Let's take a look at my amazing Desmos. So we can see here that that's equal to 2.112. Okay, so 2.112. And we can see for this one, that's not true, that the equation's not being displayed as the constant or coefficient, because I would need it to be equal to the constant coefficient, or in this case, 33. So 1, it's not true. Let's check number 2. So same thing, I would put g of 0 is equal to 33 times 0.16, 0.4, and then 0 minus 2. Okay, so when we plug this in, I'm just going to write this as an exponent. This would be 1 over 0.4 squared. And that would be equal to 33 times 0.16 multiplied by 1 over 0.16. And oh my goodness, isn't that crazy? These are going to cancel. And I'm left with that g of 0 is equal to 33. And we can see that that's exactly what I want, that it's being displayed as the constant or coefficient, which is 33. So therefore, I can safely say that it's going to be option B. 2 only. How amazing. Let's continue the journey into a similar problem, but different. So here it says the functions f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? So here right away, I can see that this is an increasing exponential function. And whenever it's an increase in exponential function, that just means like as f of x increases, x also increases. So what does that basically mean? That there is no maximum value. The maximum value I can only determine in decreasing exponential functions. So in this case, right away, I can just be like, well, it's definitely not 1. So with that alone, A is gone, and so is C. But now we have to check, is it true for g of x being equal to 0.73? Because here it is decreasing exponential. And so remember that when it's a decreasing function, it's as f of x, or in this case, as g of x decreases, x increases. I hope that makes sense. It is amazing. And it tells me that x is equal to greater than or equal to 0. So I know that the maximum value of each function is going to be at x equals 0. Well, just for this function, because it's decreasing exponential. And then just as you saw that I did in the previous problem, g of 0 is equal to 9, 0.73, plug in the 0. Anything raised to the 0 power is equal to 1. So this is equal to 9. And we can see that the constant coefficient in the original function, it's 9, and it stays as 9 here. So this is displaying the constant or coefficient at the maximum value, in this case where x was equal to 0. So therefore, this one is also 2. Oh my goodness, how amazing. Okay, looking at another function. So this one, the function f is defined by f of x is equal to a square root of x plus b, where a and b are constants. In the xy plane, the graph of y equals f of x passes through the point negative 24, 0, and f of 24 is less than 0. Which of the following must be true? So here, whenever they give 2 pieces of information, it's good to plug them into the function and see what the output actually is. So I'm going to do that for f of 24 less than 0. And we're just going to go ahead and put it into our provided function. So I just put 24 and we'll plug in 24 for x. And note in the problem it says f of 24 is less than 0. So if f of 24 is a square root of 24 plus b, this is all less than 0. Okay, that's interesting. Something that's also interesting that so either a is negative or everything under the square root is negative, but this can't be because on the SAT exam, you're never going to have a negative square root. So like can't be negative. And if that can't be negative, this guarantees that a is negative. Therefore, a is negative. And some students might come at me and say, but what about imaginary numbers? Imaginary numbers are not tested on the SAT. There will be no negative square roots. It's not possible. So I know for sure that a is negative. And next, I'm also going to do negative 24, 0. Let's take a look at the function. So our f of x is 0. A, plug in the negative 24 for x. And then, so here I have that 0 is equal to a times negative 24 plus b. So I know either, in this case, a must be 0 or negative 24 plus b must be equal to 0. Well, here I've already determined that a is negative. So I know for sure that it's going to be that the square root of negative 24 plus b is equal to 0. Why? Because 0 times something will be 0. I'm using the 0 property. Okay, so then to further solve this, I'm going to square each side. So I get negative 24 plus b is equal to 0 and add 24 to each side. And I get that b is equal to 24. So I know b is positive, 24, a is negative. So therefore, b is greater than a, or a is less than b. And that's the amazing answer for that. Wasn't it so good and so amazing? Continuing our journey. More functions. So cool and so amazing. Okay, so function f is defined by f of x is equal to x plus 6, x plus 5 multiplied by x plus 1. Function g is defined by g of x is equal to f of x minus 1. So g is the same as x minus 1. So all you need to do is basically put in x minus 1. And for the x value, do d d d. And in this case, this will give me, so this would be x plus 5, x plus 4, and x. Okay. And we're told dot 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 in the x, so it has x-intercepts at a0, b0, and c0, where a, b, and c are distinct constants. What is the value of a plus b plus c? Okay, so well, technically we would have to set each of these equal to 0. This case already x is equal to 0. So x equals -5 and x is equal to -4 and x equals 0. And that would be like in regards to a0, it's like -5, 0. B0, it doesn't matter what order or which ones are which, just to put values in place. So here I can see like a will say is -5, b it's -4, c is 0. Whereas for the value of a plus b plus c, well, a plus b is going to be, oops, -5 plus -4, which is correct answer, -9. And that is the amazing answer. Lunas, how amazing. Okay, this one. The exponential function, the value f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or base? So the coefficient or base is going to be 50, 80, 128, and 205. So all you have to do, for example, is put in f of 1. That's equal to 52. This would be 1 plus 1, which would be the same as, well, 50 times 4, which is 200. And 200 does not equal to the constant or coefficient base of 50, so I can discard A. And then I would just go ahead and do that for each of the choices. I can already see what the answer is, but for learning purposes, I will write everything out. So this would be, well, 80 times 2, that's 160, and 160 does not equal to 80. So also doesn't match. This one, f of 1 is equal to 128 to 1 minus 1, which will be 128 raised to the 2 to the 0. Remember, anything raised to the 0 power is 1. So this is 128 is equal to its constant or coefficient. And ding, 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 we have a winner. And that would be the answer. Wasn't that amazing? I'm going to stop there. I think you guys got it and thought that it was so great and amazing. Okay, so continuing. This one, Cow measured the temperature of a cup of hot chocolate placed in a room with a constant temperature of 70 degrees Fahrenheit. The temperature of the hot chocolate was 185 at 6 p.m. when it started cooling. Okay. The temperature of the hot chocolate was 156 degrees Fahrenheit at 6:05 p.m. and 135 degrees at 610 p.m. 610 p.m. The hot chocolate's temperature continued to decrease. Of the following functions, which best models the temperature of cow's hot chocolate minutes after it started cooling? So looking at these, I can see, first of all, that they're passing in 5-minute intervals. So here I could say that's the starting point. So like seconds was at 0 and temperatures at 185 degrees. Then we can say here at 5 degrees, or sorry, after 5 seconds has passed, the temperature should be at 156. And then after 10 seconds has passed, the temperature should be at 135 degrees. So those are coordinates to help me see the function a bit better. Also, quick scan of the answer choices. I can see that this one is increasing, and it clearly says that it's continuing to decrease. So I can immediately discard A and not even think about it. I actually know what the answer is because I know Newton's law of cooling, and that's what's being tested here. Maybe us physics nerds here could know it. But if you don't know it, which many people may not, you don't have to know it for the exam, you can still get it correct. We can answer this. So what we could do is just, for example, if I type in B, and B is a trap answer, I would say, because if I plug in how much time has passed, so 0 is equal to 185 times 0.85 raised to the 0, I do get that, T of 0 is equal to 185, which is what this says. However, it has to be true for also these two coordinates as well. And we can see that if I plug in T of 5, and type in 85 to the 5th power, that needs to give me an output of 156. So typing that onto Desmos, our amazing calculator built in on the Blue Book app, it gives me 82.0.85, blah, blah, blah. So that's not going to work because it should give me an output of 156. So discard B. And let's check C. So we said B doesn't work. C, same thing, we can do T of 0, which would be 185 minus 70 over 0.75 over 0 over 5. So to the 0, essentially, which this would just be 185 minus 70, which is 115. Multiplied by 1, which we can see right away it has to be 185, so that one doesn't work. So D must be our winner. But let's double check and be safe per usual. T of 0 is equal to 70 plus 115, 1.75 to the 0 over 5. This will be 70 plus 115, because all of this, anything raised to the 0, it's 1. And we get T of 0 is equal to 185 degrees. It will also work for the other two coordinates. But you see, like, if you get two choices that do give you the same output, in this case 185, then you do have to double check the other coordinates provided to you or the other values. So, and just to show it will work out. So I want this to be an output of 156. And I'm going to see if that happens. Actually, instead of me pausing, you can just watch me amazingly type it into Desmos. So 70 plus 115, 0.75. And then we had this raised to 5 over 5, which is 1, but just to show, we can type it in like this. And that gives me 156.25, which that's, well, it's 0.25 over, but there's probably some decimals. It's approximate. It's very close to. It's not um, more than one off. And therefore, that will be our answer. And if what I said before, this is basically testing Newton's law of cooling, which is room temperature plus initial temperature minus room temperature times whatever the factor of decay is, in this case, 0.75, raised to time. Okay. Aren't these problems so cool and amazing? I hope you're enjoying them. Okay, so let's look at this one. So this one, the function f is defined by the given equation where k is a constant, f of x equals k 1.83 raised to the x power. The value f of x increases by p% for every increase of x by 1. For which of the following functions where k is a constant, does the value g of x increase by p% for every increase of x by 1/4? So okay, so basically this is saying that when I increase x by 1/4, the output multiplies by p%, which will be 1.83. So that's basically what I need to see. So this one, what we can do, I mean, you can always test with g of 0. However, in this case, when I do that, this would be 0 times 1/4. This is just going to give me that g of 0 is equal to k. So that doesn't really tell me anything if it's increasing by 1/4 or not. So now I'm going to increase it by 1/4 and do 1.83. And this would be like 1/4 times 1/4, which gives me g of 1/4. And let's see what that equals to. 1.83 raised to the 1 divided by 16. 1 divided by 16. Yeah. So that gives me like k is being multiplied by 1.03849 da da da. And I want it to be multiplied by 1.83. So A doesn't work. Let's check B. So same thing. I can just so you can, well, I'll just show it. When I do g of 0 and I plug in the 0 for x, yet again, we'll get 0 times 4, 0. So I do get, again, that g of 0 is equal to k, which is interesting, but I want to show that it's increasing by 1/4. So I'm going to increase it by 1/4. And we can see this would be 1/4 multiplied by 4, which means that when I increase the function by 1/4, it's going to give me, it's increasing by the percentage of 1.83, which is exactly what I want. So therefore, I can stop there. Wasn't that so amazing? Okay, so hopefully you're getting a hang of functions, and make sure that you have these down for the SAT exam. I'm making this for the June 2025 SAT exam, but this is for really any SAT exam. SAT loves functions. You're for sure going to see them. In what capacity? Who knows? But these are very heavily tested function problems, and perhaps you'll see them on your SAT exam. So I hope this helps and that you ace functions on your SAT. And that's all I have to say for this video. Catch me in the next video. Like, rate, subscribe, share with your friends, tell everyone you know about this, because the more people we help, the better the world will be. Okay. World peace. Okay, so thanks for watching. See you in the next video. Bye, guys.